Signal and motor control conductors are generally not considered current-carrying conductors for several reasons. Firstly, they are wire-sized for control purposes, not for carrying significant loads. Secondly, they are typically insulated for low voltage, for example, 24 volts. Thirdly, they are used for transmitting signals or controlling motors without supplying power to the load. However, there is an exception for large starters or contactors. If the holding current of a large starter or contactor exceeds 4 amps, the conductors feeding it may be considered current-carrying conductors. This is because the high holding current can significantly contribute to the circuit load calculation and may require larger conductors to comply with electrical codes and standards. Conductors feeding solenoid valves, other low current control devices, and signal and motor control applications with holding currents below 4 amps are typically not considered current-carrying conductors. However, if these loads are concentrated in a confined space, they can still contribute to the overall circuit load and should be considered when designing the electrical system. Ultimately, the decision of whether or not to consider low current control circuits as current-carrying conductors is based on engineering judgment and compliance with applicable electrical codes and standards. It is important to consult with a qualified electrician or design engineer to assess the specific needs and requirements of the electrical system. Several factors should be considered when determining if control circuit conductors should be treated as current-carrying conductors. These include the conductor size, the voltage rating, the actual current draw, grouping and proximity to other conductors, and the applicable electrical codes. Smaller conductors are typically used in control circuits as they are only intended to carry low currents necessary for signaling or control functions. If the conductor size is significantly smaller than what would be required for power distribution, it suggests that it is likely not intended to be a current-carrying conductor in the traditional sense. Control circuits often operate at low voltages, such as 24 volts direct current or 120 volts alternating current, compared to power circuits that might operate at 208 volts, 277 volts or 480 volts. The insulation rating of the conductor should match the voltage level it is expected to carry. If the insulation is rated for low voltage, it is an indicator that the conductor is part of a control circuit and not a main power distribution circuit. The actual current drawn by the control circuit is a critical factor. If the current is consistently low, below 4 amps for example, the heat generated in the conductor is minimal. This is especially relevant when considering dilating factors for conductors in close proximity. Conductors grouped together in a conduit or cable tray can experience increased ambient temperatures, which reduces their ampacity. According to the National Electrical Code, NEC, if conductors are bundled together or run in close proximity, their ampacity must be derated to prevent overheating. If control circuit conductors are bundled with power conductors, this derating must be considered, and it might influence the decision to treat the control conductors as current-carrying conductors. Local and national electrical codes, such as the NEC in the United States, provide guidelines and standards for electrical installations. These codes often specify conditions under which conductors must be considered current-carrying and how to calculate ampacity and derating factors. It is essential to adhere to these codes to ensure safety and compliance. For example, NEC Table 310.15. The 3 outlines adjustment factors for more than 3 current-carrying conductors in a raceway or cable. These factors reduce the allowable ampacity of the conductors based on the number of conductors present. If a control circuit conductor carries more than a negligible current and is grouped with other current-carrying conductors, its ampacity must be derated accordingly. Engineering judgment is also important. It may be necessary to consult with a qualified electrical engineer or inspector to make a final determination based on specific circumstances. They can assess the overall electrical system design, conductor sizing, and potential heat generation to determine if the control circuit should be treated as current-carrying conductors. In summary, while signal and motor control conductors are generally not considered current-carrying conductors due to their low current draw, small size, and low voltage operation, there are exceptions. If the holding current of a large starter or contactor exceeds 4 amps, or if multiple low current control circuits are concentrated in a confined space, these conductors may need to be treated as current carrying conductors. Adhering to electrical codes and exercising sound engineering judgment are crucial in making the correct determination.